You're given zero index integer array of integers nums, a prefix nums. This is important from 0 to I. Okay, I was missing this 0. So a prefix nums from 0 to I is sequential if for all j which is greater than 1, greater than or equals to 1 and less than or equals to I, nums of j has to be nums of j minus 1 plus 1. In particular, the prefix consists only of nums of 0 is sequential. Okay, return the smallest integer x missing from nums such that x is greater than or equal to the sum of longest sequential prefix. So, okay, let's understand the problem. Okay, we have 2996, smallest missing integer greater than sequential prefix sum. Okay, so this is the problem statement. In the problem statement, what they're saying is you have given an array, let's call it as A, whose length is n. Okay, we need to find a prefix sum. Okay, we need to find smallest prefix sum such that when you're taking a number from 0 to I, okay, you should take a number from 0 to I such that when you take index j, iterate over it, this from 1 to I, so your nums of j will be nums of j minus 1 plus 1. And when you're doing a prefix sum from 0 to I, in such a way that this condition holds good, so you'll be having a prefix sum. Okay, once you have that prefix sum, you need to check if that prefix sum exists in the array or not. If that exists, then you need to take other next prefix sum. So you'll have to do prefix sum plus plus, and you'll have to check again in the nums if it is there or not. Okay, if it is not present, then this is the smallest prefix sum that you need to return. So let's take some example and you will definitely understand. So we have array as 1 2 3 2 5. Okay, so in the question what they've said is you will have to take the prefix sum. Okay, when you take prefix sum from 0th index, this is 0th index, first, second, third, fourth. Okay, this is indexing. So from the 0th index, if you see, these three are continuous, and yeah, and its prefix, I mean, if you do sum of this, it will be sum is 6. So when you try to check this if 6 is present in this array or not, so you don't find. So this is the smallest prefix sum that you need to return. So in this case, your answer will be 6. Okay. Now let's take one more example and we'll understand now here. Um, you have 3, 4, 5, 1, 2, 112, 14, 13. So now if you see this array, you will have to always start from 0th index. Okay. So 0th index you will be starting. You'll check. You'll be checking from this index, like if the previous element is one less than the current element, it is correct. Like it is in sequence 3, 4, 5, right? This number you can take now. And here also you can see 12. No, here it is not sequence. In case, let's say if it were like something like this, 13 and 14. This is also a sequence, but this sequence will not be considering. Let's say you have this also, it's like 15. Okay, you have 4 sequence, but you have just your 3, but you will not be taking this sequence. The reason being, you'll always have to start from the 0th index, right? From the 0th index, whatever prefix you find, uh, then you'll have to consider from the 0th index. So from the zeroth index, if you see, it is in sequence like one greater than previous, one greater than previous. Now here it is mismatching. So you'll be taking these three sums. The sum is 12. So when you try to find 12 in this, array, so you had here 14 and 13, right? So sum 12 is present. Now you'll be taking sum as 13. Next number you'll find 13 is also present. Now you will take sum is 14. 14 is also present. Then your sum is 15. So 15 is not present. So this is the smallest prefix sum wherein we'll have to return. Understanding, right? So I'll take one more example. Just give me a second. So we'll go to problems, and we have smallest missing. Now let's go to submissions, and I have one test case. So this is a test case wherein our answer was, something. I'll tell you. Let's go back to iPad. Example array we have is 37, 1, 2, 9, 5, 8, 5, 2, 9, 4. So yeah, this is the array now. So if you see, you'll have to consider from the zeroth index, whichever are the continuous elements. Here only one element is the continuous, like 37. We don't have 38 here, so we'll be taking just 37. So in the prefix sum, your prefix sum is going to be, since this is just one continuous element, so your prefix sum is going to be 37. Since 37 is already present here, you will check 38. So 38 is not present here, so your answer will be 38. Okay, as you can see, our answer is 38. So let's try to solve this problem. So what we'll have to do is we'll be taking one prefix sum, which is initially 0, and I'll be taking one set in order to make sure um, whatever prefix sum we are finding in nums, that we'll be doing in a of1 time. Basically, all the elements will be inserting in set, and we can check in of1 time. So that's the reason. Now I'll take one more element as previous, and since the vector length is always 1, so one element we will be having. So nums of 0 minus 1, I'll make sure it's a previous element in order to just make sure ki, this is our continuous thing. Okay. We can do this way or we can do other way also. I'll tell you, don't worry. So we'll have to check if this previous plus 1 is equals to nums of I. So it's like we have a continuous elements. So if it is a continuous, then in prefix sum, we're going to add this nums of I. Okay. Yeah, we'll be adding nums of I. Else, it's like we have, broken down the, um, continuous elements. So in that case, we need to break. So, yeah, we'll be breaking here. And every time we'll have to make sure your previous element is nums updated to nums of I, the previous element. In the next iteration it will be the previous element, and in the set you'll be inserting this nums of I every time, so that you're doing a operation of 1. So when I is lesser than n and it is breaking, so you're not inserting all the elements into set. So I'll make sure if I is less than n, I'm just inserting nums of I and then increasing I, so that all the elements are inserted into set, and whatever prefix sum we have, we'll check here if set dot count of prefix sum If that element is present, count will be greater than 1. So if it is present, then you will have to check the next smallest prefix sum. So you'll be doing, once it is not present, you'll have to return this prefix sum. Okay, let's try to run it. Okay, n we have not defined, so let's define n as nums dot size. Okay, so it's a variable naming convention. Now let's try to, take this test case and run. So it is running fine. Let's try to submit. Yeah, it got accepted. So in this way, you could have, easily solved the problem. The main thing was like from the nums of 0 to I, sequential element will have to take. And that's the main thing here. And yeah, and you'll have to calculate the prefix sums. And in order to look into this array, since here n is small, like 50, you can not use set, and you can make sure time complexity is increasing. But yeah, let's use set so that we are checking if that prefix sum is present in the array in a O of one time. So yeah, thank you guys for watching the video.